A satellite is orbiting in a circular orbit around a planet whose distance is orbital distance is small r. And obviously, if it has a certain speed at this point, so that is the orbital speed. So we can say that this object, this satellite, have the two energies right now. The one is the kinetic energy 1 over 2 mv square, which is actually in terms of gravitational field constants and terminology, we can also say gmm over 2r. That's a kinetic energy, remember that. Plus, what is the potential energy? Negative gmm over, that's the potential energy. So if you sum these two, which gives us the total energy, and according to this question, the total energy is written by this symbol. So we can say that the E is equals to, if you sum it, then it will be negative gmm over 2r. So this is the energy right now this satellite have, which is at the orbital distance r from the center. So if you have to move it from this r to the orbital radius 3r, which means you have to further move it 2r. So it means somewhere you have to move it in a new orbit whose orbital radius is 3r. 3r. So how much will be the work done? That's the question. Okay, so let's find it. So important thing that we had already covered is the total energy. So satellite possess this energy while orbiting at a distance r. But if you have to move it to this final position where it will have a new energy, of course the total energy will change, and that will be negative gmm. I'm applying the direct formula for the total energy, right? So 2 in, like, you remember I told you it's a negative gmm over 2r. So I'm just changing this because we always write orbital distance at this place. So you know the orbital distance is 3r, because this is a general formula, negative gmm over 2r. So what will be the total energy will become, that is negative gmm over 6r. So how much work is done? Because you see that when you will do a work on this satellite to move it from the one orbit to another orbit, you have to take it away from the planet, you have to take it against the gravity. So energy have changed. So how much energy have changed? Let's simply calculate that energy. That change of energy will be equals to the work done. That's so simple. Okay, so what is a final energy? Negative g m capital M small m divided by 6r minus into minus open bracket, so it will be gmm over 2r. We can take let's say g capital M small m over, why not 2r? So inside what we have, 1 over 3 minus 1, right, which you can further solve. So this will be 1 minus 3 over 3, so that's the negative 2 over 3. Okay, and negative 2 over 3 inside negative gmm over 2r. So do you remember what we have said here, that negative g capital M small m over 2r is the total energy, which they also say here is E. So can we replace here? So what it will be then? So finally the work done is equals to negative 2 over 3 into E. So this much is the work done, and you have seen that this work is negative because you are taking the object away from the planet against the gravitational field. So the right answer is obviously option D, negative 2e over 3.